Hello everyone, my name is Nachiappan and my project is about design and simulation of a mild hybrid electric vehicle. These are the topics that I have included in this project presentation. This is the drivetrain configuration of a mild hybrid electric vehicle. It is similar to that of a conventional drivetrain. The only difference is that a small electric motor is added between the engine and the transmission. It acts as a starter, generator and a traction motor. The engine and the motor are mechanically coupled to the transmission. These are the 6 operating modes of a mild hybrid electric vehicle. The first one is the engine driving mode, in which the engine is supplying power to the wheel, and the second one is the motor assistant mode, in which the battery and the engine are supplying power to the wheel, and the third one is the motor driving mode, in which the battery is supplying power to the wheel, and the fourth one is the charging mode, in which the engine is supplying power to the wheel and to the battery, and the fifth one is the regenerative braking mode, in which the wheel is supplying power to the battery, and the last one is the ideal stop mode, in which both the battery and the engine power are disabled. This is the vehicle propulsion architecture of a mild hybrid electric vehicle in autonomy. The first row represents the engine components and the second one represents the motor components. The objective of this project is to come up with a design which has a better fuel economy and low CO2 emission, and the parameters that are considered for implementing this design are the engine power, motor power and the type of transmission. And I have used a DOE approach to compare the fuel economy and CO2 emission. As you can see from the table and the graph, I have varied the motor power from 10 to 15 and the engine power from 98 to 58 and plotted the fuel economy for all the combinations. As you can see, for a combination of 58 and 15, I'm getting a better fuel economy, which is 43.1. The first table and the graph is for urban cycle, and the second one is for the highway cycle. As you can see from the graph and the table, for the same set of combination, I'm getting a better fuel economy, which is 51.67. These are the comparison of CO2 emissions. I'm again varying the motor power and the engine power, and I'm plotting the CO2 emission for plotted the CO2 emission for a different combination. As you can see, for a combination of 58 and 15, I'm getting CO2 low CO2 emission of 185.78, and this one is for urban cycle, and for highway cycle, for the same set of combination, I'm getting low CO2 emission of 154.94. All these values are for auto transmission. In this slide, I'm comparing my auto transmission with CVT transmission. As you can see from the graph and the table, I'm getting better results for better fuel economy and low CO2 emission for CVT transmission. These are the results for my best design. First one represents the state of charge of the battery for both the cycles, and the second one represents the engine torque for both the cycles, and the third one represents the motor torque for both the cycles. And these are the engine energy storage, which is a battery storage, power input, output and loss for both the cycles. And this represents the engine power input, output and loss for both the cycles. And these graphs represents the motor power input, output and loss for both the cycles. These are the brake specific fuel consumption for both the cycles. The green line represents the best operating line, and these are the motor speed versus torque graph for both the cycles. The blue line represents the propelling torque and the red one represents the regenerating torque for both the cycles. And these are the summary of results for my best design, which is a CVT transmission with a motor power of 15 and engine power of 58 kilowatt. You can see the fuel consumption of 47 and 51 respectively, and the CO2 emission of 169 and 154 respectively. The best fuel economy and low CO2 emission is obtained for the following combination of engine with engine power of 58 and a motor power of 15 and CVT transmission. And this design is implemented using autonomy. These are the references that I have used for doing this design. Thank you.